Alright everyone, let's go ahead and get started today. There's a decent amount to cover, but let's still start with one of these geography games. I've kind of like maxed out all the ones that I really know, so let's just like play one of the old ones again basically. So this is the one, remember, it gives us like the outline of a country, and then we have to guess what country it is based on the outline. Yeah, maybe someone can just shout out one. Yeah.
Ireland?
Ireland. Wow, is this gonna be right? Okay, nice. So we got it in the first one. I think there's also though, like you can then, if you get it right quickly, you can click on like neighbors, for example. And then now we have to guess like which of these are the neighbors, or maybe we type out the neighbors. I don't know. Yeah, will it be United Kingdom or? Yeah, must be. Okay, nice. Now what's this one?
Some island.
I actually have no idea. Does anyone know? Yeah, do you know it?
The Faroe Islands.
Oh, is that FAR? No. Okay. It must not. Is it like directly border Ireland? I don't know. Is there like?
No.
Yeah, someone. But yeah. Alright, this is your game.
The Isle of Man.
Okay. Oh, got it. Okay, nice. That was pretty impressive. Okay, let's go ahead and start with the lecture though. So today's lecture we're going to keep talking about like Git workflow and sort of integrate it with your project teams as well. A few announcements though. First, some reminders for Project 4. Remember, Project 4 deadline was extended to Sunday night. There's no design document you need for that. There's a modified process journal you should check on the website for what we're expecting there. And again, we want you to upload your GitHub Copilot chats, okay? And there's also instructions on the Project 4 write-up for how to do them. Next, okay, so there's code walkthrough presentations in a week and a half, okay? So starting next Tuesday, we're gonna start having these code walkthrough presentations. We're gonna try to get through 5 or 6 per lecture. So Tuesday we'll try to do half of them, Thursday we'll try to do half of them. I took a look at the signups. I think most teams have signed up. I think we're missing 2 teams. So there's sort of like a tentative deadline that we have for the group project. You can check the code walkthrough presentation. We want you to sign up for your topic by tomorrow, so please do so. And one reminder, there were a couple of these topics that I wasn't sure if you were presenting your own group project idea, which is not the goal here. Remember, you want to select an existing feature in the code base, okay? So something like the idle-lib debugger, or I think code completion is one of the features there, or like replace and find. So just pick something that already exists and talk about it for 12 minutes and then leave 3 minutes for a Q&A, okay? So if right now your topic is what you're currently doing your group project on, you'll need to sort of modify that, okay? And then the instructions for it are on the website. We have a few requirements here. Basically, if you hit these requirements, you'll get a very good score on the code walkthrough presentation. But I think last lecture, there were a couple of questions about like what exactly we're expecting here. So at a high level, you want to understand an existing feature or like piece of code in the idle-lib code base pretty well, but you don't have to explain like your line-by-line understanding or exactly what like variable values are set to when certain things happen. This is more of like a high-level understanding to, like you want to give a high-level understanding to the rest of the class, okay? So this is maybe like a outline of what you could do. Say you were doing like the call tip feature, okay? And to be clear, I think someone can still choose the call tip feature, even though we did like a small in-class activity on this. It's totally fair game, I think, for a code walkthrough presentation. First, you want to just demo the feature in action, like what is the feature that you're going to be presenting on. You'll want to definitely have a good diagram of the feature. This is one of the main requirements here. You'll want to make a nice diagram and have it, prominently displayed on a couple slides. Like it could be multiple diagrams, it could be one diagram, but make sure it's sort of like well presented in your slides. You might want to like go over some like high level like classes or objects that are used prevalently throughout the feature. And then you might want to do some code navigation, right? Like you can, for an example of this, you can even look back to, I think, lecture 3 or lecture 4, where I think I did like a code navigation demo on a certain feature. I can't, remember now which feature, but you can sort of look back at those like earlier lectures where we covered these like code comprehension techniques, and you'll just want to do something very similar to that, okay? And then maybe you'll want to focus in on one key method. Remember, we don't need to understand everything that's happening in the feature. I don't want you to talk about like everything that's happening in the feature. That would probably be like, it'd take too much time to do that. You might want to focus in on one key method and then make a small code change or just show the effect of what a certain couple lines of code are doing, and then make the change, run the application, and then we can actually see the effect of that code on the final application. And maybe if there were some pieces of syntax that was new to your team that you had to like understand through Googling or ChatGPT or Stack Overflow, I think that also is grounds for what you might want to discuss. Okay. We're gonna have a 12-minute time limit and then 3 minutes for question and answer. Okay, so please try to practice this to make sure it's within 12 minutes. I'm getting a bit worried about the amount of time. I don't want to have this take 3 whole lectures, so we're going to try to be strict for the 12-minute presentation. And you might want to practice before so that we don't have to maybe like cut you off after you pass 12 minutes. Are there any questions about the code walkthrough presentation or the signups or what we're expecting here? Okay, cool. And then the next thing is that the final project checkpoint is due next Thursday. Okay, so from 1 week from today, you should come to class. We're gonna have like a sort of almost like an office hours type class where we will have some activities for you to do like in your group, but we'll be like checking in on the specific projects that like me and the tutors are specifically like supervising. And you'll have a chance to talk us through what you've done so far, and maybe we'll give you some advice on what you have left. And just an announcement related to this, we now have like a lot of sort of like instructions or pieces of advice for doing this group project. So I would highly recommend following sort of the links here. The main one that is upcoming is the project checkpoint instructions, right? This is what is due next week. But you can just kind of see like how we're going to be grading this and what the sort of expectation is. Basically, you'll just need to be making a comment under your initial GitHub issue proposal. Remember, you proposed 2 different GitHub issues. You'll just need to make a comment underneath that, going over like what you've done so far, what the challenges are that you've run into, and then design documents like that includes your changes up until now or your plan up until now. It doesn't have to be finalized at all, but it should just give us a good understanding of what you're planning to do for the rest of the project. Okay. So this is sort of what we're expecting for the actual checkpoint, but remember you should be sort of making progress up until then, and you should be explaining what progress you've made up until the checkpoint. Okay? Are there any questions about the project checkpoint or just anything related to the final project? Okay, and I just want to quickly go over like what the grading is going to look like for this. So there's going to be like 10% of your grade is going to come from the project checkpoints. You're in the final exam slot, we're going to have like the presentation for each group. That's going to be 30% of your grade. The sort of like final, it says final report. It should really be like final pull request or just like final, feature. We're going to grade that for 40%. And then project management. So this is stuff that we talked a bit about last time with the GitHub projects. You should just have some like task management board. And we'll be looking through like your commits and your pull requests and your code reviews. And that's also going to be 20%. I'm going to go over that in this lecture though, like what we sort of expect for the code reviews and the Git commits and stuff like that. Are there any questions about the final project? Okay, so hopefully y'all are starting to work on this or have already had a few meetings. I think if you haven't already, maybe like setting up 1 to 2 meeting times per week would be a good idea, and you can sort of work outside of those meetings and just catch up or like touch base during those weekly meetings. Okay, so let's start with today's topic about code reviews, okay? So, y'all have been on one side of the code reviews where we have been starting to give comments to you, right? You've already received code reviews for Project 2. I think most of you have received it for Project 3. If you haven't, I'm going to talk about Project 3, about halfway through the lecture, but if you haven't received your feedback for Project 3, you'll get that by the end of today or maybe early tomorrow. But y'all have sort of received code reviews, but what y'all are going to be doing for the project is actually giving code reviews as well, okay? So what the sort of expectation here is that y'all are going to be having GitHub, like you're going to make branches in your repository, and you're going to be having pull requests just like you're doing for submitting the projects right now. But then your group members will need to like review those pull requests. So the same way you've been getting comments from like me, Yash, Charles, or Cushy for like code quality issues, or maybe I think we haven't asked so many clarifying questions, but you might want to be asking your teammates like, oh, what is this line of code doing? Why are we doing this? Those are sort of the things that we expect in a code review, okay? So this is, just some general guidelines for the code review. You want to like really think through the design of the like code that you're reviewing. You'll probably want to make sure that the code is working, so you can actually like pull the code that your group partner has sort of made a pull request for, try it out on your end, and make sure it's working before you approve it. Same thing that what we've been doing in the code reviews. You want to be looking for good variable names, good code style, good formatting, etc. Okay. And so actually to start this, I just want to go ahead and do the first activity, which is going to be related to code quality. There's actually like so many cool examples from the projects, actually, like project 2 and 3, of these different like approaches people took. And let's just start with y'all sort of giving your own opinion or trying to like understand which of these approaches is better code quality. And most importantly, I want you to try to explain why you think one of these like pairs of approaches is better code quality, okay? So you'll go to this bit.ly here, and let me just quickly explain what's happening here. So it's hard to present it all on my screen, so I do recommend sort of going to the website and opening up the slides on your end as well. So there's gonna be like 3 pairs of code snippets, okay? So there'll be like option A and option B in each of these pairs, and there's just gonna be like 2 different approaches for part of the project, okay? So this first one is in project 2, and you can see like the code snippet in editor and the code snippet in query, okay? And you can see that there's sort of like a difference, especially in the query.py here. Same thing for pair 2. This is for project 3. This is related to the show code outline feature. I've sort of put in the white arrows, like the main differences between the 2 things, so you don't have to read every single line. You should try to understand the code, but the white arrows are pointing out like the differences between the code snippets, okay? And the same thing here. Pair 3 is on 2 slides, okay? We have 2 different sort of approaches for pair 3. So take some time first individually, look through each of these, and I want to give y'all a little bit of time here to think through which of these is better code quality, and then give your justification for it, okay? So go ahead and just start that.
There's no action. There's no action change in the top.
Yeah, the top ones are the same. Okay. Yeah, and then pair 1, the editor.py are the same actually. It's just the difference in query. y'all actually submit the Google form, then discuss with your like group what your sort of answers are, okay? To see if y'all sort of agree on the reasoning more than just which answer is better.
For A, I feel that's the to use the parents because messages it's just a string problem for me. So it's kind of weird to use
Yeah. I probably I just mean I could have just had it. Just give me like a thumbs up if you're Make sure you also submit the Google form. This is the only form for attendance today, so make sure you submit it before the activity.
I just thought.
I had a similar class. I thought, well, I was more about like, if you are just holding our school structure, it's easier. Yeah, I guess it's
Okay, let's go ahead and go over these. So please make sure we have, like, you submitted your response here. Okay, we have 33. That's probably most of y'all. Okay, so let's go through each of these. For pair 1, okay, so like hopefully you'll realize editor.py is the same. The main difference here is we're doing this sort of like string operation on self.message, and other one we're like getting the end index from self.parent, which was self.text. So can somebody maybe share with me what your group came up with for which of these was better, but more importantly, like your reasoning for why you think one was better than the other? Yeah.
So I said that option A is better because for option B, you use self.parent.index. From what I saw in the query.py file, there's no guarantee that the parent object has an index function. So if you do that, then there might be like some cases that doesn't work. Whereas if you do self.message.split, since the message is just a field of the query class, it'll always have a split function.
Okay, interesting. Does anybody else have a different answer or a reason for it? Yeah.
Yeah, that was option B. I think option A kind of creates coupling with the query message. For example, you want to switch around the order and say enter a positive integer between 1 and total lines, and then put something after that. Then when we parse the -1 index, it would go to something else, and that wouldn't be total lines anymore. And so option B kind of solves that going directly to the parent, which is kind of always going to be raised in the query class. And so that's going to be in the method. It's very easy.
Okay, awesome. So it's cool that we got 2 different answers. I do just want to re-emphasize this point about code quality, that there's always going to be trade-offs between different things. Like maybe one thing is more readable, but it's longer, or maybe it's a bit more like maybe there's slightly less coupling for something, but I don't know, maybe you have an extra dependency somewhere. Okay, so there are going to be like trade-offs with all these decisions, and I think you can reasonably make an argument for a couple things. Actually, the thing, Joshua, that you mentioned, I don't know. I'm curious to know, like, if there is a time where parent doesn't have the dot index. Sort of my understanding here was that self.parent is always going to be equal to whatever the value for self.text was in the go to line event. But again, it's totally possible that I'm wrong in this. Just the reasoning here is that self.text is how we access the last, like, the total lines in the go to line event. And then we are passing it as the first parameter to go to, which is a subclass of query, and the first thing is parent there. But maybe that's correct, and you can maybe let me know if there are.
I was more referring to like a general case, not really like specifically text.
Okay. So maybe it's true then for like other subclasses of query, like section name, for example, is something that uses the query base class. Maybe that might be the case, but I do think since sort of this code is limited to the go-to class, I think the right one is a little bit better. And yeah, so the reasoning for this one, again, in sort of like our view here, like the core staff view, is that this does have this like extra coupling disadvantage. Coupling basically means that 2 parts of the code base are like very closely tied, such that if you change one thing, you then have to figure out the impact that it has on the other thing. Okay, and so the reason the option A is maybe not so ideal in this case is exactly what what the answer was, like the answer that was given. Sorry, can you remind me of your name? Julia. Okay, awesome. Just like what Julia said, where if we modify the actual thing here, so the answer I was sort of going to go over is like, say we say we want to like clarify the message and have it be enter a positive integer between 1 and total lines inclusive. Now we have to sort of reevaluate what our method or what our line and go to is going to be, and probably have to change this as well. Okay. Whereas with the other approach, we don't really have to worry about any changes to the message, but maybe if there is some change to parent or like what the type of parent is or something like that, then we might have to worry about that. But this was just something that we saw in a few of these submissions, and I just wanted to point it out, and so hopefully you can sort of get an idea of our reasoning for why we would have suggested a change to using self.parent. But this was super creative, actually. I think I saw a few of these, and I messaged the tutor staff, and I was like, wow, this is, I never thought that this could be one of the approaches, of just sort of like sending the value in the message here, and then Charles was like, oh, this is what I did for my project last year, and so it was like interesting to know that, I don't know, I just totally missed that, but it was a pretty cool approach, so if you thought of that, that is pretty creative. Nice job. Okay, pair 2. So yeah, it looks like the main difference here is in option A, we have the outline list, okay? And actually, this is probably slightly, I shouldn't be just writing the list outline, it should be writing like a joined version of the list outline with like a new line character in between. So I think that's an issue when I was creating this example. Let's assume this is the correct output, okay? Versus this one where we have self.pyshell.write inside of these like if and else. Does anybody want to share which one of these they thought was a better approach and why? Yeah.
I thought option A was a better approach because you're just like collecting all of the occurrences of like def, or like all the lines that contain def and then class into like an array, and then like you would join them later on and then you print that. And I think actually for debugging purposes, it would actually be better to have that, because then you can see the variable and see like what line you like.
Oh yeah.
And then with option B, like if you're trying to debug that, you're just printing each line every time you see it. So you can't really debug that. It doesn't get saved anywhere. It just gets output to the shell.
Oh, that's a good point. I didn't even think of that when I was like, thinking of this example. But yeah, I think the reasoning there that you're mentioning is that in like the debugger mode, when we sort of step through the code, we can actually see the full value of outline, and maybe we can see like what it should be. We can sort of maybe know what it should be and then see what it actually is, and it might be very easy for us to decide there. Yeah, that's a great point. I also think option A is better, but the reason that I was thinking here is actually, I think a lot of people actually have something similar to this. Okay, the main thing in option B here is that we have a call to self.pyshell.write for basically every single line that has a def, like a function definition or a class definition. Okay, so say we have like a really big file with like 10,000 functions. Okay, we would have 10,000 different calls to self.pyshell.write, okay? And in a very small file, when you do this feature, I think the runtimes will be very similar, where both option A and option B will probably be like, less than a second. But if you do have something similar to option B, try copy pasting like a really massive file, or like, have a few files that you copy paste from like the idle code base and try running the show code outline. It takes quite a bit of time for like everything to actually appear. And so the reason there is just sort of like efficiency, kind of, that it actually is like a quite significant, like it'll take more than, 5-10 seconds depending on how big your file is, if you have all of these individual calls to pyshell.write, okay? And actually there was a student who had sort of done this in project 3, and then I asked them to do like the timeit function, where they, in Python there's this function called, I'm going to show you, timeit, where you can give it sort of like a command to run, and it tells you how long it took, basically. And when we ran the timeit command with like option A, basically it was like less than half a second or something, and with option B, for a very big file, it was like over 3 or 4 seconds or something. So this is like another example that we saw commonly in project 3, and hopefully, hopefully you can check your own code and make sure that you didn't have option B. If you did have option B, one of the changes we're requesting for project 3 is to just modify it to be like option A, okay? So think of like how in project 2, one of the main things we suggested was like, if you didn't use self.parent, we sort of requested that change. This is going to be one of those similar changes that we're requesting for project 3, okay? All right, and the next one. So for pair 3, we have option A, which kind of has like self.isFunc. It has these like 4 different functions that return true or false value, okay? And the opposite, we have basically those whole functions that are just like a single line in the correct or appropriate place. So does anybody here want to give a guess on which one they thought was better between A and B? Any answers? Yeah.
I think option B. I mean, obviously, because when you write helper functions, you want it to like make the logic a little bit like flow easier or easier to read. And then, I mean, these are like one-line helper functions, so why not just plug them back into it?
Okay. Any other answers here? Again, this is subjective, so yeah, go ahead.
Nice. I think a good option. I didn't write this, but I think an option might be neither, where you just use the regular expression.
Okay, so it's a fully different sort of approach.
It's a totally different path. but, yeah.
Okay, cool. Yeah. No.
In terms of lines of code, the other one was, has less lines.
Yeah, this is much shorter. Yeah. Okay, so maybe this is one of the more nuanced examples. I can definitely see the trade-offs here, and I'm also less convinced on like a clear-cut answer here. I'll tell you sort of my reasoning, but again, I don't think there's really a wrong answer here. I thought option A was better, but not for like readability reasons or necessarily like length reasons. I thought it was better for testability reasons. So I think we would probably want to check our ability to detect, functions or classes. And so when we have something like this, we can individually test each of these like 4 helper functions basically, right? And I think one of the big parts of project 3 is like making sure that we are correctly finding the functions and classes. And so, we could still, like say we did have this approach, we could still be testing all these different sort of scenarios, but we would just need to maybe have a bit more thought into like when we're actually testing, what is like the dummy code that we're going to put in and what are we sort of expecting. I just felt with option A here, we can very easily sort of test is func, is class, get func, and get class. And then also one other sort of like like maybe another sub reason is that we can then like actually reuse some of these lines of codes or some of these methods basically. So I don't know if it'll directly help for project 4, but in project 4 you have to find the function definition of whatever function call your cursor is on. And so you wouldn't be able to directly use one of these functions, but the idea more here is that the more that we sort of separate or like modularize our code into like these sub features or sub functions or sub components, we can then maybe like reuse some of those later on, even outside the context of this, for example. But I do totally agree. I think like this code, option B, is actually pretty well like named in terms of variables, and it helps that there's like Python functions like starts with and split that are pretty easy to read and understand what it is. So I actually don't think this code is like that bad at all. The main learning point though I wanted to give for this was just the like testability and like modularity, okay, which is just like breaking it into smaller components, and that helps a bit with testing. One other thing I did notice is that in project 3 there were a lot of like maybe a bit more extreme versions of this where we had like a single function that was like, show code outline event, and it was like, maybe like 40 lines long or some like really long number of lines where there was maybe a couple different for loops or maybe a couple different like if else blocks. And typically when you start getting to several different like things that are happening in a function, that is a good indication that maybe we should sort of refactor and break it down, okay? Like, for example, I think, again, this is not so bad, but there were a couple examples of, like, multiple sort of iterations through whatever, like, outline variable. Like, first just to get the things, and then second, we went through the final list of, like, definitions and classes to, like, sanitize it or to clean it and then to output it. So yeah, the main idea here was just separation can help with testing and maybe even help a bit with like code organization. Are there any questions about any of these 3 pairs or just any other points people wanted to bring up in terms of code quality? Okay, so the thing I want to point out here is that these examples were maybe a bit more unrealistic because you're getting to see 2 examples or 2 approaches of doing this and having to choose which one is best. When you're doing code reviews in your group, you're not going to have like 2 examples, right? You're just going to see the code that's in front of you. And so rather than like, I just think a good approach when you're doing these code reviews is to just keep some of these like issues in mind and sort of apply it as you go, okay? So if you just start to think like, oh, I wonder if these things are coupled, remember, you don't have to be right immediately in your code review, right? You want to maybe ask questions or hop on a Zoom call or meet in person with the person who made the pull request. But just sort of like keep these principles in mind as you're doing the code review, and that can help you out with identifying code quality issues, okay? And remember, similar to how we're grading the projects, we'll be looking through the code that you add for the group project for maybe some of these code quality issues. And so the more that y'all can do to sort of like recognize that, then we'll have less sort of changes to request or have less sort of like things to point out for code quality. All right? Maybe I'll just make sure y'all understand what these are. So like readability, maybe just like good variable naming. Coupling is we just don't want two things to be too interconnected, okay? Changing one area shouldn't like make us have to change the second part of the code base. Modularity was like breaking things into smaller modules or smaller components. Testability, if we want things to be able to be unit tested, right? So things that have a clear input and clear output, those things are very unit testable, okay? So that's sort of another thing we want to emphasize. Yeah, maintainability relates to like documentation. It relates to like documentation and maybe like good code organization so that changes later on are sort of easier to make. Efficiency is just maybe like runtime, like if we're making a bunch of calls to one sort of long function, we probably don't want to do that. And then reusability, that was the sort of point of this isFunc, isClass code example. Okay, so now I just want to go over project. So part of the reason of doing this activity is that, hopefully you notice a couple of these are things that you might have even done in Project 3. So we're not going to require you to like do the change from like pair 3 where you then have to like break it into smaller methods or anything. But the few things that we are going to like request changes for is one, having this like code outline feature in its own file. I think some of y'all just added a feature to editor.py, which I could definitely see why that is the case. Then you don't have to add another file, you're sort of limiting your changes to one file. I think the sort of convention that the idle-lib codebase or idle-lib developers have used so far is each feature, assuming it's sort of a large enough feature, is getting its own file, similar to like code context. And so we're gonna sort of like ask that you have the implementation in its own file. You can look at the ZZDummy class for that. Trying to change your code to have a single call to PyShell.write. This is another one that we're gonna request. And then stuff you've seen before, like removing extra or unnecessary new lines. And then this other one is pretty interesting. It's like having a comment at the top of the code outline file. So you might have noticed, I think some of y'all use code context to sort of like emulate for adding your feature. Most of these, actually I think almost all of these files have like a descriptive comment of what that actual feature is and maybe what it does, and also maybe any information about that feature that is helpful for developers. I think some people still had like the ZZDummy comment up here, or had some like commented out some code that was previously there from ZZDummy or some other files. So we'll just sort of request that you add a very similar piece of documentation. And then lastly, the 3 arrows for a new PyShell prompt. This was maybe more of a minor one, but after you show the code outline, you should show the 3 arrows immediately such that you can start typing in the Python shell again, okay? And this just requires adding like a single line of code. There's a method in the PyShell class that helps you show the prompt. So I'll just leave it at that, but these are gonna be some of the changes that you're gonna be expected to make. And we're gonna have the deadline for making the changes by Tuesday night. I'll actually write that in the announcement. Let me just say project 3 changes due Tuesday night, okay? I think that's gonna be May 21st. Okay, so are there any questions on like project 3 grading, code quality, how we're gonna be grading the project, anything like that? Yeah.
Did you say when it's due?
Project 3, like the changes requested are gonna be due on Tuesday midnight, okay? And I think the goal here is that we're requesting less changes, less intensive changes than Project 2, so we can get those in a bit sooner than Project 2. Okay, let's go ahead and talk about Git branching, okay? And so again, like in all of these lectures, starting from even like this past Tuesday, think of all of these lectures in terms of your project, because these are things that we expect you to adhere to as well as you're working on the project, okay? So, this is sort of how we expect the branching to go for your projects. And this is something very similar that you've already been doing in Project 2, 3, and 4, okay? Where we don't want you to be directly modifying the main branch, okay? You're actually going to be making a separate branch that's called a feature branch, okay? And that feature branch, you want to give a decent amount of thought into like what is the scope of this branch going to be. So maybe maybe your project is just a single feature, okay? And in that case, you would just have a single feature branch, but then, you know, the 3 or 4 of you would have these different sort of smaller branches breaking off of it, and then that's when you'll be doing like the pull request to merge it back into the feature branch, okay? So, on the other hand, your project might have like 3 or 4 smaller features, right? Maybe you're just making a set of changes to the display of the editor window, okay? And so maybe part of it is like adding a sidebar to see all the files, and maybe another thing is adding like highlight, okay? You're gonna wanna take some time to figure out what the different feature branches are going to be, and then like the next layer is what are the different development branches going to be, okay? And I think the development branches, that is something that would be more of like an individual taking charge of, okay? So like, let's say for like this example, your team has a single feature branch, you would have 4 different smaller branches, but you'll also want to like name those branches and plan those like development branches such that it's very clear what the contribution of that smaller branch should be, okay? And then when you make the pull request, you'll want to summarize what is happening in this development branch, and you know, just like what you've been doing, maybe give some context or some helpful like design decisions or reasons why you made the changes that you did, okay? So if you've already started modifying the main branch, I think try to maybe copy those changes and like, you know, revert the main branch back to however it was when you originally got the repository, and start making your changes in a feature branch and then eventually a development branch, okay? Because this is something, the way you're eventually going to submit the final project, you can see in the bottom right here, there's going to be like a final pull request from the feature branch, or maybe feature branches, into main, okay? And that's what we're gonna like, you know, grade as a big part. That was like the final report. That's really like the final pull request. That's what we're gonna be grading for, seeing like all the code changes, the design documents, your documentation, stuff like that, okay? So like, please do adhere to this sort of convention and take some time to figure out what that branching process is going to look like, okay? Oh yeah, so this is maybe just something we had from last year. I thought this is a helpful visual here, where these are different sort of developers, so for A, B, and C, y'all each might be working on your separate feature or separate development branch. Your separate, yeah, development branch. I think we should say, let's say develop sub-branch A. Let's just do that. Sub-branch, and then these are what's going to be merged into your feature branch, and then your feature branch is eventually going to have a pull request to the main, okay? And of course, we want you to be giving these code reviews and making pull requests for each of these development branches as well. So what I wanted to do now is actually give you all some time to talk with your team about what the feature branch or branches are going to be. And then like maybe start dividing up the work right now, or start dividing like what the individual development branches are going to be. And you can start even like writing this as a comment in your GitHub issue. So let me actually just show you what I mean by this. So when you go to your group project, okay, just taking a second here. And when you go to your team, so we are a secret staff team, and then when you go to like issues, you can even start sort of writing right now like what your comment for your group check-in is going to be. So you might want to like start making a list of what are the different like sub, like let's say development, like you could just like feature branch, name is going to be something, and then like development branch 1, and then assign it to somebody. You'll maybe want to make a separate issue for that development branch, and then sort of like keep planning out this way and sort of decomposing your eventual feature into these smaller development branches, okay? Do people sort of understand what y'all could be doing these next like 5 to 10 minutes? I just want to make sure y'all have time while you're all together to sort of plan this out. Are there any questions before I just let you all elaborate for a few minutes? Okay, so yeah, take some time to plan out the feature branch and the development branches. No. You didn't have to do the You can.
After today, I'll
You want to call? I guess
taking that CD have one ready. Also have one
But you can take liberty to name it like whatever.
Yeah, that's like it basically combines all of the small stuff. I just feel like our that's like yeah, they don't. But run off without saying this
So it might be something like you have to and after the are like net you know what I mean? If it's like something that requires you to know what the changes are, if you just have to do this both of those things are independently.
Well, just so fast.
Okay. It depends how you if it, to me, it sounded more like a single feature where it's just like when the user does something, there's something that goes backwards. And then those two other things sound like so I can totally see like how it's like minus 2%, you know, even like not maybe they're different like short term, so it's kind of up to you, but you don't have to leave all the
Yeah, we also said
I'm so tied to it. I'm so tied to it.
So that would just be whatever. You want to just describe it, talk about why you use certain decisions that you use, so whether like design like somewhere like
Oh, really?
I've never actually thought about this. And just like, okay, how far?
We'll just give a couple more minutes for this, okay? So just 2 more minutes and then we'll continue with that lecture.
It's just like, oh my god, it's like,
And what can be paralyzed. It's like oh, wait. I mean, that's 25.
but isn't that us? Just we have this right.
Oh, yeah, are y'all talking about the right?
Yeah, it's like what we're supposed to do.
I didn't even realize that. That's like we had an example of last week. Not having to save them.
I did say too.
Is that oh, is that? I didn't know that because the main thing is actually and he maybe then you know get that part.
They gotta have
Yeah.
But guys, this is great.
Yeah, tomorrow. All right, everyone, let's reconvene, sort of. So hopefully you had a chance to discuss right now, like what your feature branch is going to look like, or feature branches and development branches. Keep in mind you don't have to name it feature and development. You probably want to pick a name that is sort of relevant to your team, okay? And then same thing with the development branches. Those should be like smaller subtasks of the feature, okay? So don't just call it like feature branch and then development A, development B. It should sort of like be clear to the people who are reviewing and people on the team, like what each sort of like branch and sub-branch is doing, all right? And then a couple other things I wanted to point out just for like integrating, GitHub issues with GitHub projects, and then like linking pull requests and issues. So one thing that you can actually do is you can link these issues. Okay, so this is an issue in my group project repository. Okay, I remember last lecture we showed you how you can link it to specific things in projects, right? Like here I connected it to our GitHub project that's called Secret Staff Team Project, and then you can set a status for it as well. You can make all these updates through the GitHub issue. Then you can also link it to a specific branch or pull request, okay? So here, you'll first have to like select the repository. So I think this is the group project one, and then we have, you'll be able to see the different pull requests or branches. I think we haven't created any branches right now. But then you can sort of link it to these, okay? So that, I think, is going to be really helpful for people who are like us, the tutors and like instructor who are going to be reviewing this, but also think of it as like, y'all are working on this project right now. It'll be done during finals week, and then y'all will leave, right? But the way most of these software teams will operate is that maybe some people will like leave or be off the project, but then there's going to be new people that are sort of like onboarded to it, right? And so there's this like extra dimension of making sure people who are going to be working on the project later, but maybe when you're not there or not on the same team, like they should be able to understand the history of the project and be able to like trace back different changes, look through like, oh, when was this feature added? When was this feature added? What were the different commits and like what things happened in those commits? So also think of it from that sort of point of view, right? And that relates to like the maintainability that we mentioned earlier, that it should be something that is not too complicated to read and understand, even if the developer or the core developer team is like absent, okay? So yeah, try to think of it from that. I know it's a bit hard to replicate that in a class environment because maybe after this class you're not going to look at this project again, but maybe that's something to keep in mind as you go off into potentially working in an internship or an industry. So, all right, are there any questions about this activity that we just did, about the branching or pull requests or code reviews, anything like that? Okay, and I realized I just wanted to show a quick example of what the code review like interface looks like for y'all. So this is like what, how me and the tutors have been grading everything, but when you're on like the repository, you'll click pull requests, okay? So I just click that third tab here, pull requests, and then you'll be able to see all the open pull requests. You can also click the closed ones and see any ones that have already been merged or maybe that have been sort of like discarded or deleted. And so when you click on one of these pull requests, first you see like whatever the commit message was. I literally asked Cushy to do this like 30 minutes ago just to make like a very simple change because I wanted to show you all the example. But you can see like all, there's a very short summary of like what is going on here. Added a file with print statement for in-class example and also the location, which is really helpful, right? So you can then see the commits. Normally you'll probably have several commits in a pull request, right? You don't want to just be making all your changes, one commit, and then a pull request. You might want to sort of even decompose the smaller tasks, right? Like when you make changes to one file, save that, make a commit. And then you'll make changes to another file, save that, and commit, okay? So you'll be able to see the commits, and then also the files change, okay? So the files change is probably the main thing that you want to be looking at in a code review. And again, this is like a very simple minor change, but what I do want to point out is this is how you actually review the changes. You'll like click this button, click this like review changes green button here, and then this is all in like markdown, so you'll want to say like nice job, I don't know, love the change, okay? And so then you have an option to either comment, approve, or request changes. Typically, when you want them to make changes, you'll request changes. But you can also make specific like inline comments, okay? So this is something I wish we did more of as a course staff when we were looking through the projects, just to show y'all how this works. I think typically y'all have just got these like bulk comments that, once I make this review, and then like you'll be taken to like the main pull request page, and you can sort of see the dialogue, okay? Like you can see Cushy's initial pull request and then the comment that I made. But one thing that is really helpful for making like specific requests or changes to specific lines, or pointing out empty new lines that you want to change, you can like click just like the plus that's next to that line and say, I don't know, why is there a space between CSE and 190, okay? I don't know, just something random like that. And then you can just like add that comment, or you can click start a review and it'll be like starting a whole new code review. But then when you go back to that pull request, you should be able to see also the individual inline comments, okay? So this is sort of what we're expecting y'all to be doing. When we eventually grade your group project, we should be able to see, like several closed pull requests. And then there will probably be one single open pull request, and that'll be your final sort of submission, right? And so that single final pull request is something we will review. You won't be doing the individual reviews for that. You won't be merging those. Again, you'll be like giving reviews and merging all the other ones that will have now been closed, but there will be a final pull request from your feature branch to main, and that's what we will review and sort of grade, okay? But this is sort of how you'll go about doing the code reviews and monitoring the pull requests for your team. Are there any questions about this, about the code review process? Okay, all right, let's get to the last topic for today, which is like, I don't know, one of the worst things that you might deal with, which is it's gonna be merge conflicts, okay? This is also just like personally something that's very difficult to like encounter when you're actually working on this. So we have like a sort of like simple demo here that I'm gonna show, but keep in mind that this is going to be on like a single file, okay? Like I'm just gonna show you a demo on like a very small file. When it's in a large code base, there'll be multiple such like merge conflicts. I'm just gonna show you how you can use like the inbuilt sort of like VS Code merge conflict viewer to go about like fixing any of these merge conflicts, okay? So first, like what is a merge conflict? So yeah, we can actually, there's a great visualization for this, that if we have like, and this might even happen in your group, okay, where you'll have two different like development branches, okay, and maybe you end up having to modify the same piece of code, okay, so like, you've branched off from feature, which say there's like no changes right now to sidebar dot update sidebar, okay, to this update sidebar method. And then independently, you and your teammate realize like, oh, I have to make some change to update sidebar. And then your other teammate is like, oh, I also have to make a change. But y'all aren't like working together for this part, right? Y'all are all maybe working on your own individual sub-feature, right? So then eventually, when both of these branches, maybe one branch gets merged in first, and eventually the later branch is going to come in, they're going to have changes to the same part of code, okay? So I'm going to go through a very simple example to show you like when this happens and how to sort of like get around this, okay? So first I'm just going to create like a simple new folder. Let's just say merge demo, okay? And let's just open this in VS Code. So right now there's no files in here. I'm just going to make a new file and let's say test merge, okay? Testmerge.py. And it'll be in merge demo. So right now, let's do, okay, so this one actually, let me make this bigger. Gerald did this demo last year in this class, and I actually, like, I feel like I learned so much about this. So this thing is like meaning of life, okay? And it's return 42. Has anyone heard this before? Like why the meaning of life is 42, or just heard that the meaning of life is 42? Yeah, some people have heard this before. I feel like I heard this when I was younger too, and then I just was like, Oh yeah, that's so cool. The meaning of life is this random number. Does anyone know why it is 42? Oh, okay, way more people knew than I did. Someone just want to like share what the reason is? Anyone that has the, okay, yeah, go ahead.
Hitchhiker's Guide to the Galaxy.
What's up?
Hitchhiker's Guide to the Galaxy.
Oh yeah, they mentioned it in that, right? Okay. Any other reasons people have heard of why it's that? Okay, so maybe actually, yeah, I learned this last year too. So why is the meaning of life 42? And also, let's do, so this is actually the reason that I think it popped up on Google the first time I asked it. But the reason is, so if y'all know what the ASCII table is, it's basically like a mapping of different characters to numbers, okay? So when you're actually sorting something like in Python, you have like the letter A, the letter B, the letter C, and then you do sorts, okay? What it actually does, like how it knows A is before B, is because it has like a number for each of these letters, okay? So you can see like capital A is 65, capital B is 66, okay? What it actually does is it converts these like letters to their ASCII values and sorts it that way, okay? But the reason here is like, so 42, the ASCII value for the star, okay, is 42, and the star in like regex and like programming just means everything or anything, right? So if you've seen like, you know, in the file paths when you like include like, I don't know, documents/star, it'll be like everything under the document subdirectory, okay? So that's actually what like the, I guess, origin of it was. Let me just make sure that what like this, okay, yeah, the number 42 is the answer to the ultimate question of life. That's the Hitchhiker's Guide thing. But I think, I'm surprised that now the Google search isn't showing up. I promise I'm not just making this up, okay? It has to do with the ASCII value for the star being 42, which is pretty interesting. I at least didn't know that connection before.
So Google had a Easter egg where it typed that, it'll show up the calculator, which is 42.
Oh, what is the answer to life or something? Okay, interesting. So, all right, let's just get back to the example here. So, let's say we have this like very simple file, okay? And then again, just to like a reminder, what this is about like getting into merge conflicts and how to overcome them, right? So right now, yeah, we did get a little bit off track there. So okay, so right now I just created a new like directory and then created a file, right? So right now, if I do git status, it's not gonna be a Git repository, okay? Because we haven't sort of like initialized it. The way we create it as a Git repository is this git init command, okay? So now we can see that we have we're in the main branch. People can see this, right? Is the text big enough for people to see? Is that right? Okay, cool. So right now I just have this single file. I did git status and it says that this is an untracked file, okay? Right now I haven't added it to anything yet. So let me actually do, I'm gonna create a new branch, okay? I'm gonna do git checkout -b my branch, okay? So right now I'm on a new branch called my branch and we can do git status and it'll tell you what branch you're on. You can also just do git branch and it'll tell you, oh whoops. Okay, I thought it'll show me what branch it is, but maybe I'm doing the command wrong. Anyway, so right now we're on my branch, okay? We're gonna make some change here. Let's just say we do like if, okay, let's just do like if, yeah, this was what was coming up earlier. So let's say like if 1 equals 1, we're gonna return 21, okay? This is gonna be like a very simple change that we're making to this branch. And then let's just do git commit, or sorry, let's do git add test merge.py. And then git commit -m, I don't know, added a condition for if 1 equals 1, okay? Okay, so now we have our own branch called my branch with this change. But then let's actually go back to git checkout main, okay? So this is, whoops, git checkout is a master. Hold up. Git checkout -b main. That's weird that it was like this. Okay, so let's say this was the original thing that we had, right? Now we're on a branch called main that is just going to be looking like this, okay? But then let's do, like, let's say if 2 equals like 4, okay? Then we're gonna return 84. Okay, now I hope, let's just do git add, git commit, added condition for if like 2 equals 5, okay? Whoops. I need to do -m negate commit. So -m here. Okay, so let's see here. So okay, right now we're on main, and this is what main looks like. And now let's do git checkout git checkout my branch. Okay, so now we're on my branch, and now this is what the code looks like, right? Just the main difference here is that this if statement and this return are different, right? And so now if I do something like git merge main, oh, it just did it. Okay, hold on. Let me. It should. I thought it would give a error there. So let's just do like print. This is a test. Git commit. Added print statement. Wow, this is interesting. I want to cause a merge conflict and I'm like unable to. Git add.
Of course, it merges perfectly.
Yeah, it's actually crazy. Okay, so I'm going to save git commit -m added print, and then let's just do git branch or git checkout main, and then let's just do I don't know. Let's remove. I don't know. Okay, let's just try this. And do git merge my branch. Oh, git commit -m trying to get a merge conflict. Okay, hopefully this works now. Git merge my branch. Okay, thank God. Alright, so this is what a merge conflict looks like, okay? It'll say auto merging test merge. It'll tell you the file name. Okay, remember this is just like a single file. This isn't a big code base, but it'll help you. It'll specify maybe the file or files that the error is in. And then it'll just say like fix the conflicts and then commit the result, okay? So what I wanted to show is just like this view actually, where it'll tell you what the current change is on the branch that you're currently on, okay? And you can tell based on whatever is under these like arrows and head here up until all the equal signs, okay? And then everything below is the thing that you are trying to bring into whatever branch you're currently on, okay? So you can see here what we had before was return 34, return 18, and then here we just had, I guess, a few different return statements, right? So here are the different options that you kind of have. You might end up having like multiple such conflicts, okay? And so you'll have multiple areas where it's showing like what you currently have and what you could be importing in, okay? For each of these decisions, you're going to have to either accept the current change or accept the incoming change. So you have to decide between the two branches, okay? Here, this is like a really important lesson in like how you want to communicate with your team about this, okay? My sort of like intuition here, like what I would do in this situation is before making any decision, because remember you and your like group mate have worked separately and y'all are making these different changes for different reasons. You know why you made those changes, but you might not know why your group mate made those changes. This is where you'll want to either, okay, so you might want to do this, which is like give merge -- abort, okay? And then it just like does like undoes everything, which might honestly be the best approach in that specific moment because you'll actually want to talk with your group mates first and figure out why those changes are happening and what the best solution is, okay? But now let me try getting that again. Okay, so we're back to the merge conflict, okay? Say you now are with your group mates, you're talking through it, and you realize, oh, I actually want to keep what I had written because that was sort of the better approach here. When you just click accept current change, it just like, you know, gets rid of whatever the incoming change was and just goes with yours, okay? And then let me just undo that. And the opposite, accept incoming change, it'll just default to whatever that like merged branch originally had, okay? You could do something like accept both changes, but this is just going to sort of like concatenate the two things together. Typically, this won't be correct because a merge conflict only happens when you're writing to the same spot in the code. So it's very rare that it even makes sense to have both changes. if it made sense to have both changes, it would sort of like automatically merge it. Remember when I tried to get a merge conflict and it didn't happen and just sort of like added the two or like sort of accepted the changes together? That was probably fine because I guess I didn't make changes that actually conflicted with each other, okay? So let's just say we want to like accept the incoming change. Now we'll want to like actually save this, okay? Let me do resolve and merge editor. Okay, I don't know why. Oh, it's doing the like the inbuilt git like configuration, but let's just do it through the command line. So now we've like made these changes and we want to do git status. Oh, maybe since I kept the original changes to this branch, I don't need to actually like make any of these changes and sort of commit it. But since you're going to be making changes during these merge requests, you might end up changing the file, and then you'll just have to go through fixing the merge request, and you'll do git add, git commit, and then you'll sort of be done with that merge conflict, okay? It might be more complicated than this because you'll have multiple such conflicts. In that case, this like inbuilt VS Code viewer for merge conflicts is very useful. It has a simple like sort of toggle where you can jump through all the different merge conflicts and accept or reject all of the different incoming changes. But again, the main point here is that you shouldn't just assume your changes are correct. You'll want to talk with your group mate and then maybe do it with the person who had the branch that is causing the merge conflict, okay? All right, so that is going to be it for the lecture. I think a couple things, final project checkpoint next Thursday. I know I kind of promised a practice skill demo today. Hopefully y'all aren't disappointed that it didn't happen today. That's gonna happen on Tuesday, okay? No pressure there, just come with a laptop that is charged, okay? Because you'll be doing a small in-class activity for about 30, 40 minutes. All right, enjoy your weekend, everyone. See you all next week.
What?